Hi everyone. In previous video, we understood what is containerization, what is virtualization, and what kind of problems they solve in the IT industry. In this video, we're going to focus on why we use containers on top of virtualization, what are the use cases, and the different kind of container engines which are available. In a previous video, we also explored how hypervisors help create virtual machines. Now let's dive into what are the advantages of using virtual machines that is not available in containers. Each VM runs a full guest operating system. We saw this in our previous video also. And this makes it completely isolated from other VMs and host machines. So in other words, this reduces the attack surface. So even if a VM is compromised, it won't affect the other VMs or the host. This makes it suitable for running multiple workloads with different security levels. Containers, on the other hand, share the same host OS kernel, which means they are not as isolated as VMs, and a container breach could potentially impact the host system or other containers. Since each VM has a dedicated virtual hardware, that is a CPU, memory, and disk, VM tends to perform more consistently for intensive applications or workloads that require a very strong resource guarantee. The full OS and the hypervisor provides a stable and predictable environment for these kind of workloads which are resource intensive. What if you can get the best of both? That is running containers on VM, and what are the advantages? First thing is better isolation. So virtualization provides a strong isolation by running each virtual machines on a separate guest OS. And containers, when they run inside a virtual machine, this will allow lightweight process level isolation on top of that, and this also reduces the attack surface and increases the security. So running containers inside a VM will allow organization to apply different security policies at each layer. Let's take an example. For example, role-based access control RBAC. So you have VMs running on containers, and when I apply a RBAC policy, the VMs and containers can be managed independently, allowing a fine-grained control over who can access a virtual machine versus who can manage and deploy containers inside them. In a multi-tenant environment where different users or if you or your customers, when they run workloads on the same infrastructure, if you combine VMs and containers, this will enhance the security. So VMs will isolate the tenants at the infrastructure level, and containers will further isolate individual applications or microservices within the each tenant VM. This enhance the better security of managing the infrastructures, because VMs will provide an extra layer of isolation with a minimal footprint. And by running lightweight containers inside a VM, the underlying OS and hypervisor remains untouched by the containers, which reduces the attack surface compared to running containers directly on a shared host. So other advantages of running containers on VM is better resource efficiency. So if you see, VM includes a full OS and it consumes more resources, which we see takes gigabits of size, whereas a containers take only MB in size. So containers, as on the other hand, because they share the same OS kernel, it makes it more lightweight and efficient. So running containers on top of VM will allow better use of the host system resources. So imagine a company that runs multiple applications on a cloud infrastructure. Initially, they set up 3 VMs for 3 different applications. Each VM runs its own operating system, which will take a significant amount of CPU, memory, and storage. The operating system alone will take up gigabits of RAM and storage level, and this will lead to fewer resources for the actual application. Now, let's say the company decides to migrate these applications to containers while still running them inside the existing VM. So instead of having each VM run a full OS per application, they use containers that share the same OS kernel, and this eliminates the need for each application to run its own OS, significantly reducing the memory and storage overhead which generally a VM will take. So for organization heavily invested in VM-based environment where they're very well versed in how virtualization technique works and they're not ready to just go on to a containerization, completely on containers. So when you run containers running within the VM, this will enable them a smooth transition to modern containerized workloads without requiring a complete infrastructure overhaul. The next advantage of running a container on VM is it allows you to apply strict controls over the operating system and its configuration, which is important in cases where if you are a financial institution or you have strict compliance and regulation. So this will make it easier to comply with regulatory requirements in industries like finance, healthcare, or government. Say, for example, a financial institution handles sensitive customer data such as personal financial records and transaction histories. There are regulatory frameworks such as PCI DSS, that is Payment Card Industry Data Security Standards, which govern the storage, processing, and transaction of credit card data. If you need to comply with the PCI DSS, the company must meet strict controls related to the OS hardening. The operating system must be hardened by disabling unnecessary service, patching vulnerabilities, and enforcing very strict firewall rules, which is important for an OS hardening. The operating system must be hardened by disabling unnecessary services,